So let's look at the Fourier coefficients and the DC components. And one of the things in finding this, we repeatedly using the fact that any integration over, let's see, over t and the cosine n omega t is going to be equal 0, dt equal to 0, and also the sine n omega t dt equal to 0. The fact that the t omega is equal to 2 pi over t, that means if we integrate it over a fundamental period or multiple or integer times of the fundamental periods, and then we're gonna integrate the sinusoid, you get a 0, right? Because the area above this 0 and the negative part, they will cancel each other. That's the fact that we're gonna use over and over. We're not gonna derive mathematically. So what we are using is, let's see, if we have sine waveform, and if we integrate this over time, and this will cancel the area, right? The cosine waveform is the same. And if you integrate the one fundamental period, 1t, or if the waveform has multiple periods in this from 0 to t, and that's what this sine n omega. So this waveform cosine omega n omega t gonna repeat n times in each fundamental period. So you still integrate to 0. We're gonna use this factor over and over. So let's start looking at the DC component. To find the DC component, we start with integration of 0 to t ft dt. And right off the bat, we just utilize the fact that the cosine n omega t, all this, I mean, for n is not equal to 0, right? So all these terms are going to be equal to 0. So therefore, I have 0 to t a0 dt. I know a0 is a constant, so therefore I have t times a0. All the other terms, the integration of this term would be 0, right? Because all the AC terms. So therefore, the a0 is very easy. a0, the DC component is 1 over, and this just average this waveform over a fundamental period. Although the upper and lower limit, we could choose any starting and ending points as long as we are staying within one fundamental period. And sometimes it's more convenient choosing from 0. Sometimes maybe it's more convenient choosing from some other numbers. And we will see in the next example, actually we're going to choose a different number from the 0. And let's look at the other. Let's look and try to find it. So this a0 is very easy to find. Let's see, find a sub n. And I'm gonna do is doing from 0 to t ft cosine n omega t dt. And now I need to write these things out. So I'm gonna substitute all the ft here. So from 0 from 0 to t, ft is just the a0 plus the Fourier, the AC terms, and I'm going to replace the n by k, the index, so that I distinguish from this n here, and k from infinity, from 1 to infinity, I have a k cosine k omega t, and plus b sub k times sine k omega t, and then I multiply to cosine n omega t dt. And this is the integration I need to figure out. And the first one is the a0 times n omega t. That will give me the AC term, right? And of course, we are trying to figure out that n is not equal to 0. And n is going to equal to 1 or from the other integer numbers. And so therefore, I can ignore that one, and therefore I'm just ignore this a0 times the cosine n omega t integration, because that term is just an AC term, And now I have the sum of k equal to 1 and ak cosine k omega t times the cosine n omega t, and plus b sub k times sine k omega t and times cosine n omega t. So I just multiply them out. And dt, of course, this should be, I should put parentheses there, braces there. And now we need to look at, use the what's called the trig identity, right? I have cosine, right now I have this, the first one I have cosine x times the cosine y. The trig identity for this one here is half cosine x plus y plus cosine x minus y. And this one here is, if you have plus, that will also always give you a cosine, will always give you AC term, right? So the cosine k omega t times cosine n omega t will become half of cosine k plus n omega t plus cosine k minus n omega t. Right. So this one here is, when k is not equal to n, we will have two AC terms, and therefore their integration gonna be 0, right? So only if the k equal to n, we have half cosine 2n omega t plus 1. And again here, because cosine 0 is 1, right? So the first term, the AC term, is going to be integrated to 0. And also on this one here, if we use the trig identity, this one will always be AC term or 0. So therefore the integration for that one is always going to be 0. And the actual integration, I have more detailed derivation in the Google Colab notes. If you're interested, you can take a look at that. And so therefore the AN is going to be equal to, the integration we have here is from 0 to t ft times the cosine n omega t is just equal to half t times 0 to t times from half 0 to t, the integration a sub n times dt, and we got half t times a sub n. So therefore the a sub n is going to be equal 2 over t 0 to t ft times cosine n omega t dt. And this is for the AN terms. We can do the similar derivation for the BN terms. The BN will be ending up with BN is half dt over 2, 2 over t, and from 0 to t ft times the sine n omega t dt. And these are the Fourier coefficients. How we're gonna this is how we find these Fourier coefficients and also the DC components. Okay, so there's a little bit more detailed derivation how we utilize the trig identity. I hope you really go through this couple times yourself, so you can you're really comfortable with why we get these results. Okay, so next we're gonna look at another example on the how to find these Fourier coefficients. I'll see you in the next video clip.